by the volunteer examiner coordinator to go over these slides with you, because it is very important before we give you guys the test on the 20th. Everyone must have a FRN number. If you do not have that, I want to walk you guys through the steps on how to do that. And if anyone missed any information on this, I can email you guys this PowerPoint and it'll walk you step by step on how to do that. So that's going to be the website. You would have to create a login and password. Now, a lot of folks are saying, okay, well, I don't want to put my address on there. You don't have to use your physical address. It just has to be a mailing address. It doesn't have to be your address, as long as they have an address on file to get in contact with you in case they need to. But you don't have to put your address if you don't feel comfortable doing that. Step one is going to be to register your email with the Federal Communications Commissions. You will hit the register button to get a username or to create a username and password. Step two is once you get all of that, you'll get an email confirmation. Once you receive that, go back to the login page and log in with your credentials. And another important note is your email is your ID, your username. Once you log in, go to register for new FRN, and then select individual. This is not going to be a government agency or anything. It's just going to be just for you guys. And is your address, contact address within the United States? I hope so, but if not, you might get denied. Then finally, fill out this information. It's going to ask you for your name, contact, your suffix, and your address. Like I said, you don't have to, if you don't feel comfortable about your address being online, they just have to have some type of way of contacting you either by PO box or physical.
Exactly. You file taxes, right?
Then let's see, that's it. Any questions on that? All right.
And then close out.
Huh?
Close out and then go back to the SD card.
Which one?
Go to browse. Scroll down.
Where?
Keep going. Down further. There you go.
Ah.
He did it.
Yay!
You're now a PowerPoint master.
Yes.
Sign off your cert.
Did I pass? Did I pass?
Those ones could probably do full screen.
Yeah, you should be a full screen.
Bingo! We have liftoff. All right, guys, welcome back to the radio class. Today we're going to be covering chapter 3. I know this one's going to be kind of cut and dry, but this one is where most of the questions are going to be coming from. There's going to be 6 questions, I believe, from this chapter. But like I was telling some of you all this morning, if you're not electrically inclined like myself, don't stress over this. If you can't grasp the questions, just when you're doing your studying, just memorize the answer that goes along with the question. Like Carrie was saying 2 weeks ago, you're going to get the same exact questions that you guys were practicing, but the answers may be switched up. So on the practice test, it might be answer A, but on the test, it might be answer D. So just keep in mind of that. All right, we're going to be talking about electricity components and circuits. Who's ready? Yes. Now, and I was over here like Carrie the other day, trying to find the imaginary outlet. We're going to talk about components and units and radio circuits. Radios are powered by electricity, and radio signals are in a form of electrical energy. So, of course, if you want to power up your radio, you have to have some type of battery or cable to power on the radio.
Or crystal set.
Or a crystal set. A basic understanding of how we control electricity allows you to better install and operate your radio. One thing that to keep in mind is that the power supplies. Tom and I were talking about power supplies. The bigger the power supply is, the more amperage it's going to have, which means you can plug up multiple radios without it cutting off as a safety feature. But they make smaller amps, which I believe it's maybe 10 or 15 amps. You can run a radio off of that. But also keep in mind when you push out more wattage, you're going to be pushing out. It's going to require a lot more amperage from that power supply. So if you want to run 1,000 watts, I would recommend using the big boys, the big power supplies. Electrical charge can be positive or negative. And let's see, Kathy. I was going to use you. The red of a wire is the red wire. So if you have an electrical component, the red wire.
That's positive.
Yep. And of course, the black wire is going to be your negative. Electrical charge can be positive or negative. Opposite charges attract each other. Like charges repel. Electrical current is the flow of electrons. And who knows when the electrons are? Electrical current, let's see. Electrons are negatively charged atomic particles, usually surrounding an atom's positively charged nucleus of protons. So protons are positive, neutrons are neutral. That has no charge. Electrons move in response to an electromotive force or EMF and can move independently of atoms. Anybody have any questions on that? Basically, electrical concepts. The current is the movement of electrons measured in amps, just like we were talking about with the power supplies. And it is represented by the letter A, capital A. An ammeter is represented by the letter capital I in the formulas, and we'll go over the formulas here in just a little bit. What's that?
There's formulas? Oh,
Oh, yes. The formulas, one of the formulas is pi, P divided by I times E. But we'll go over that. Resistance is the opposition to the movement of electrons measured in ohms by an ohm meter. So it'll tell us how much ohms we're pushing out. And it's represented by R and with the horseshoe symbol in the formulas. Resistance is like friction that turns electrical energy into heat when current flows. So, an example of that is when you transmit on your handheld or radio, that resistance is going, or the electrons are moving through the power cord, and it could heat up, just like a handheld. If you notice that when you're transmitting on a handheld, the back of your hand gets kind of warm, it's because of all that electricity that the battery is providing. Conductors permit flow, low resistance, and insulators block current flow, which is going to be your high resistance. The flow of water through a pipe is a good analogy to understand the three characteristics of electricity and how they are related. So that's going to be a water pump. The water will come through the pump, and this pump flows it to the meter to either bring it down or to increase it. And then it keeps on going and around in a circle there. Then the battery's the same way. The battery will be your pump, basically. And what that battery is doing is that it's taking that electricity and taking it through the meters and back to the battery. Any questions on that? Polarity. This is very, very important. It refers to the convention that determines which voltages are positive and negative. One thing that you want to do is make sure when you have a car battery, when you're hooking up a radio to a car battery or a power supply, make sure that you connect up the polarity. So red to red, black to black, negative to negative, positive to positive. Or you could do some heavy damage to your radio, which is why they have some power cords have, a fuse in there. So if you do accidentally hook it up incorrectly, that fuse will pop and it'll hopefully shut down the radio so you can't transmit until you replace that fuse. But some radios, that fuse will pop and it'll still let you operate. But I would not recommend that because you would do some serious damage to the radio. And sometimes these high-end radios can be pretty pricey to replace or to get service on. It could be as much as a brand new radio. So make sure you guys hook up the radio correctly. Voltage from a source of electricity energy causes current flow. So what that's saying is when you get everything hooked up, like your radio to your power supply, and once you turn that power supply on, that current is going to be flowing from the radio to the power supply, and the power supply to the imaginary wall outlet here. Resistance is the material's opposition to flow the current. So resistance, just thinking that, Diane and I were going to go at it, she's going to stop me, that's what the resistance is. Voltage, current, and resistance affect each other. The higher the voltage, the bigger push causes more current. All right. And electrical current is measured in which of the following units? B. Sorry. I'm sorry. D.
Amps.
Guys are right. What is the name of the flow of electrons in the electric current?
Current.
Yes.
You said the answer.
You
You said the
yes.
answer.
Yes. So, and I don't know if I mentioned this before, but a lot of your questions that you guys will have on the test, your answer may be in the question as well.
Yep.
So look for those indicators. Hamstudy.org, that the app that I've been telling you guys about, they will highlight or in bold that what is this?
Key.
Yeah, the key point. So it's not going to happen all the time, but if you have current somewhere, if you have current in the question, you may have it in the answer. What is the electrical term for the force that causes electron flow? What was it?
Hey.
See, you guys are great.
Yeah, that looks like that.
Pretty much.
Haven't got to the formulas yet.
Then,
But then-
I said the other side.
I haven't gone to the
Wait, there's more.
formulas.
Oh, yeah, the
Yeah,
formulas.
formulas.
That's just memorization. And like I said, if you guys can't grasp it, don't stress over it. It's just memorize the question, memorize the answer, and move on. Which of the following describes alternating current? Let's see. And what's that, C?
See.
Yep, you guys are right.
See, all right.
Let me take this drink real quick. What instrument would you use to measure electric potential? Yep, you guys are right. What instrument is used to measure electric current? I'm hearing A and D. D. It's actually D. Good job, good job. All right. This is where it gets kind of,
Yeah, I was just gonna recommend, if you don't mind, there's a book, when I started all of this in like 2021. It's basically like a dummy guide, to electrical, and so you can look up like through the appendix, and it'll break it down very, very, like, to my level, and I'm probably done this one in here. So I'm just saying that it breaks it down very, very simple. So if anybody wants that book, I can give you the title and everything. But like I said, it talks about all these formulas, and like I said, it'll say polarity, and it'll go all into that, and mixers and all kinds of stuff. So
that's a good idea.
just let everybody know.
And, you know, like I said, first day of class, I am an extra amateur radio operator. I still don't know half the stuff. You know, so ham radio is, you know, we get the test done, and then when you get out, you know, playing with the radio, that's when all the fun and learning begins. But once we get through this, you guys will be experts. And
Okay.
maybe y'all can teach me some things. So, current that flows in one direction is called direct current, which is your DC. Your car batteries, which I do a lot of my ham radio from my car, and when the power goes out, but this is the nice thing, when the power goes out, you can still be operational by using a car battery. When I was at the sheriff's office during, was it Isabel? Yeah, Isabel. With Sheriff Howard, all his equipment went off the air. No 911 communications, and I had my antenna at the sheriff's office. My radio sitting there with 4 12-volt car batteries, and he said, "Alan, how are you operating?" I said, "Well, you know, I have battery backup, the batteries." He goes, "Okay, well, I need this. Okay, so I emailed through what they call WinLink on the ham radio, and up to VDEM, the Virginia Department of Emergency Management, and sheriff wanted a truckload of water, and I got that water delivered within 2 hours. So, ham radio plays a very important role, especially with the CERT team. I can't remember who's on the CERT. You are. Actually, get with me after class too. I'll talk to you about that. Current that flows in one direction, then opposite direction is called AC. That's going to be our imaginary outlet here that Carrie loves to point to. AC current reverses direction on a regular basis. Each process of reversing is a cycle, and the number of cycles per second is the frequency, which is measured in hertz. And Carrie went over that a couple weeks ago. I believe he said that the household current was 60 hertz, I think. Yes. So 1 hertz is equal to 1 cycle per second. Current flow. A circuit is any path through which current can flow. Electrical currents are made up from components and the connections between them. If 2 or more components are connected in a circuit so that the same current must flow through all of them, it's what they call a series circuit. Kenny, are you familiar with series?
What's that?
Are you familiar with series circuit? So we're gonna talk about series and parallel shortly. A short circuit is direct connection between 2 points in a circuit. An open circuit is made by breaking a current path in the circuit. So just think of the light switch. When the light switch is up, then that's when the current is going to be flowing. When you shut off the light and bring the switch down, that shuts off all the current, so nothing can pass through through the electrical. Series. So this is an example. You have the battery, the plus and minus, and a couple of light bulbs. And what it does is that the current will go from the positive and then go to this light bulb here, and then flow through the wire, go to that light bulb, and then go to that light bulb, and then back to the battery. So just making one continuous loop. Same current at all points in the circuit. Series circuits provide one and only one path of current flow. So there's nothing in between to tell her, okay, let's go this way, let's go the other way. Parallel. Parallel is, let's see. Kenny, are you familiar with parallel?
What's that?
Are you familiar with parallel?
Yeah, series, if one of the light bulbs burns out, everything stops.
Right.
And parallel, anywhere the light bulbs can burn out, the other will still be lit.
Good, I appreciate it. Like I said, this is not my expertise, guys.
Okay.
Same voltage at all parts of the circuit. Parallel circuits provide multiple paths for current flow. All right, and which type of circuit is DC current the same through all components? Well, I'm sorry, did I go too fast? The answer was a series. And which type of circuit is voltage the same across all components? Answer is B, parallel. How is the voltmeter connected to a component to measure applied voltage? It's gonna be series. Oh no, parallel, sorry.
Yeah, it was parallel, voltage and parallel.
Yeah,
Current was series,
yeah.
voltage is parallel.
When configured to measure current, how is the multimeter connected to a component? Series? Yep. We didn't talk about C at all. Or we didn't talk about in phase either. Not yet. Question, does anyone want to take a quick break?
No.
I'll
Press
finish
on.
this one and then take a break before you get to Combs Laws.
We can do that. I just want to make sure that everyone was okay. All right, multimeters. The basic electrical test instruments are simple meters, voltmeter, ammeter, and ohm meter. Those are commonly used by electricians.
Yep.
So that a separate meter isn't needed for each parameter, the multimeter was invented, short for multifunction meter. And sometimes in today's world, you'll hear a multifunction meter, or sometimes you'll hear it as a voltmeter, ammeter, or ohm meter. And sometimes when somebody asks me, "Hey, go get me the multimeter," I'm like, "Huh?" And they go get me the voltmeter. Oh, okay. So, it measures all three electrical values. Oh, we've already covered that. Other names: VOM, volt ohm meter, or DVM, digital voltmeter. So they could be, the ones now are digital, that will have that the LCD display on it. Some of the older ones will have that needle that will tell you your amperage, your volts, or your ohms. Ways meters can be damaged. Measuring voltage in an energized circuit when the meter is set to measure resistance. Yeah, don't do that. Exceeding meters voltage rating, voltmeter and leads not rated for use at the voltages to be measured. So if you have, if you need to measure a higher voltage, don't use the lower voltage probe, or it could damage your equipment. Which of the following can damage a multimeter?
C.
It is C.
See, yeah, okay.
Which of the following measurements are made using a multimeter? It's C. Now, just a little tidbit, I don't know if you guys, when you guys are doing the practice test, if it has all of these choices are correct, it may not be all correct. So if you think, yeah, let's go with that one now. Read, if you can understand that question from your reading and taking the practice test, choose the one that is right. It's not all your choices are going to be correct.
And I found on some of the tests, there's always one answer that's just kind of out there, so that'll tell you that all choices are not correct.
What reading indicates that a ohm meter is connected across a large discharge capacitor? Hear nay? Yep, you're right.
What about that one?
Which of the following precautions should be taken when measuring in-circuit resistance with an ohm meter?
Yep.
Make sure it's not powered on.
Come on.
Which of the following precautions should be taken when measuring high voltages with a voltmeter?
Yep.
Answer is B. All right,
Ah,
do we want to keep going, take a break before we continue?
Take a break.
break.
All right, break time. I know. It's too early for all this, right?
Yep.
But when we get into